Salam to all learning fellows. Hope so you will be fine. Today we are discussing about integration rules and formulas. Let's discuss the other name of integration is an antiderivative. And if there is no limit, then we can say that it is an indefinite integral. Indefinite integral. Or the other name of this integration is an antiderivative. Antiderivative. So first of all, as usual, we want to find the integration of 0. As we know that derivative of constant function is 0, so integration of 0 is the constant function c. C is a constant which do not vary. So keep in mind integration and derivatives are inverses of each other. Means the function we can derivate, we get the required answer, and the required answer integrated we can get the same function. So now we can see the derivative of integration of constant function. So integration of constant function is same as a is out of the integration as dx, derivative and integration of inverses of each other. So the final answer is ax and plus c, another constant. Third one, we can discuss about integration of 1. It is similar above pattern. 1 is out of the integration, cancel, and at the end x plus c is the integration. And next one is higher power integration. So that is not a big deal. We just increase in the power 1 and also in a denominator increase the power of plus 1. For example, here is x power n, we can write up xn plus 1. So the power is also in the denominator n plus 1 and some constant c. Again, if we want to integrate an exponential function e power ax dx, so what we can get, same function exponential e power ax, but remember that power constant which is a is also in the denominator plus some constant c. And after that, and remember that exponential function is a function whose integration and derivation is same. Means we can integrate e power x, we can get e power x. And also if we can see the derivative of e power x, then we can also get e power x. So that is a function whose integration and derivation is same. And the next one is related to exponential. You can say that x power n algebraic function, but there is a condition that n is equal to -1. Then what is the answer? Answer will be natural log of x plus c. It's mean, if we can elaborate this, we want to say that x power -1 dx, and which is equal to 1 over x dx, and we can know that derivative of natural log of x is equal to 1 over x, and so that integration of this whole function, what we get will be integration of dx is equal to natural log of x. So that is the answer, natural log of x plus c. Okay, now we can understand the concept of integration for a constant power. For example, if there is an integration of a power x dx, that is not a big deal, just like this function e power ax. We can do a power x, but remember here in a denominator natural log of a, where a is greater than 0 and a is not equal to 1. Why a is not equal to 1? If a is equal to 1, then natural log of 1 will be 0 and fraction will not be 0. So that's why we can't take this. And also a is positive because natural log of negative function is not defined. So due to these reason, we just take the condition of a positive or a is not equal to a is not equal to 1. Hope so you can understand. Now there are some more formulas which we need to discuss. These are the basic formulas, and as we discussed before, if there is an integration of constant into function, then remember that constant is out of the integration, and we can integrate function individually. So there is a property of also two or more function adding or subtracting from each other. We integrate individually, just like fx dx and plus minus g of x d of x. So both have the same answer. Also we can follow that rule or that pattern for product and division. Now we will discuss about integration of fx whole power n if there is a function and having associated derivative. If there is a function with some power n and also function has derivative, what we can do for this integration, we just increase the power 1. For example, there is a function fx, we just increase the n into n plus 1, and same we can do in a denominator. That is the required answer. Also, if we have a function in a denominator and their derivatives in a numerator, then what will be happen? Then it is equal to natural log of f of x. If there is a function in denominator and derivative in numerator, what will be happen? There is a natural log of same function fx which are in denominator. So hope so you can understand, because these are the basic rules which you can remember, and if you able to memorize it, then there is not a problem to solve the integration formulas and integration questions. Okay, now we are doing about integration of trigonometric functions. For example, if we discuss about integration of sin x dx. Of sin x, we can see that it is equal to minus cos x. So with c we can take minus, and if we discuss about cos x, then it will be converted to sin x. If we discuss about tan x, it will be natural log of secant x, or you can say that minus natural log of cos x, and cot x is equal to natural log of sin x. Secant x dx is equal to natural log of sum of secant x and tan x. Also cosecant x, it is the difference of natural log of cosecant x minus cot x. What will be the integration of secant square x? We know the derivative of tan x is equal to secant square x. So the integration of secant square x is equal to tan x, and integration of cosecant square is equal to minus cot x. Sin square x, we don't have formula related to sin square x, but we can convert it into 1 minus cos 2x over 2. So if we integrate that function, we can get our required answer is equal to x by 2, because 1, and cos 2x is equal to minus sine 2x over 2 already present, 2 of this present, so becomes 4. Also for cos square x we can do 1 plus cos 2x divided by 2 d of x. They both are same, just there is a difference of sign. So answer is also same, only difference of sign. And now after the sin square x, cos square x, we discuss about tan square x. We can prove that this is equal to tan x minus x, and cot square x is equal to minus cot x minus x. And last but not least, also we can prove that if integration of secant x tan x dx, we already clarify that this is equal to only secant x, and if there is a cosecant x cot x dx, we can see that this will become minus cosecant x. Okay, uh, do you remember that in derivative we just do that formula, derivative of cos x is equal to minus sin x, and derivative of sin x is equal to cos x. After that we just find out derivative of secant x is equal to secant x tan x. Derivative of cosecant x is equal to minus cosecant x cot x dx. And also we just do that derivative of tan x is equal to secant square x, and derivative of cot x is equal to minus cosecant square x. So these 6 formulas we discussed in derivative, but in integration there are much more other formulas just like this: 2, 3, 4, 5, 6, 7, 8. There are 8 more formulas which we need to memorize in integration process. So hope so you can understand. Now there are some inverse trigonometric function formulas. For example, you have to understand before going to exercise. For example, we have integration of 1 over 1 minus x square root d of x. So this is equal to, how we can memorize? We can memorize it through our fundamental identities, trigonometric identities. First fundamental identities tells about sine square x plus cos square x is equal to 1, and here is cos square x is equal to 1 minus sine square x. So here 1 minus x square show that x is related to sine x. So we can say that it is a integration formula of sine inverse of x. Also, if there is an integration of 1 over 1 plus x square dx, so we can see the second fundamental identity, which is equal to 1 plus tan square x is equal to secant square x. Here 1 plus this whole term is equal to x square is equal to secant square x. So 1 plus x square means tan square x is equal to x square. So that is the shortcut to memorize it for long term. After that, if we have a formula related to integration of 1 over x mod square root of x square minus 1. Remember that x mod is only in either secant x or either in cosecant x. But remember that if there is a positive sign, then it will be related to secant x. It will be related to secant x. So it is the formula of secant inverse of x. Moreover, you can verify it here because secant square x, this one is from this side, and that is equal to tan square x. So x square means this secant is equal to x. So x square minus 1, yeah, you can understand, hope so. Now if we integrate minus 1 over square root of 1 minus x square, this is a minus sign. Minus sign identify that it will be related to square root also present. It is related to cos inverse of x because same pattern, only minus sign. So we can verify that it is equal to cos inverse of x. And if there is an integration of minus 1 over 1 plus x square dx, so it's totally similar to tan inverse of x, only minus sign. So cot inverse of x. And now if we integrate minus 1 over mod of x square root of x square minus 1 d of x. So I already said that x mod is only related to secant or cosecant. If positive, then secant, and if negative, then cosecant. So there is the answer of this integration, cosecant inverse of x. I think you can understand. so we can discuss more in other lecture. So keep watching and subscribe my channel for more videos. We will meet in next video. Good luck for your preparation.